computers are different. Okay, so all these things should be understood. Okay, now we are looking at the things that we have been learning right from your childhood to the present day, and the right side one, quantum mechanical, are the things that will change the perspective of what you have been actually thinking. Universe is made up of matter and waves, but quantum mechanics says that matter and waves are one. They are not different, but you perceive them differently. That means you look at them differently. What do you mean by that, sir? Kinetic energy is different and potential energy is different only because you are talking about it. But you know that kinetic energy get converted into potential energy get converted into kinetic energy, electrical energy get converted into mechanical energy gets converted to electrical energy, solar energy gets converted. So all energy is one. Only thing is you are differentiating it. In the same way, matter and energy seem to be different. That means matter and waves seem to be different in classical mechanics, but in quantum mechanics, they are not different, but you are looking at them or you are giving them some specific meaning. Physical quantities can be determined exactly, so the future and the past can be known exactly. That's what is your law of causality. Law of causality that implies why something has happened or why something will happen can be exactly determined in classical mechanics if you know what are the forces going to act and what are the forces that have acted. Okay, అంటే ఎగ్జాక్ట్గా తెలుసుకోవడం classical mechanics లో ఉంటుంది. Okay, but quantum mechanics. Okay, now if some physicist says that okay, perfect గా కావాలి నాకు answer, that implies it does not make any sense because quantum mechanics does not accept perfection. Okay, exact values are not possible in quantum mechanics. What do you do then? You'll have some uncertainty in the final value. You have to accept that uncertainty. Okay, usually anti సినిమాల్లో డైలాగ్ ఉంటుంది. Okay, perfect గా కావాలి, perfect మనిషి కావాలి, perfect that thing కావాలి, perfect this thing. All those people who use perfect word do not understand nature and do not understand physics. Okay, so physical quantities can only be approximated, and so only possible outcomes may be given with high uncertainty. Ante there is no certainty of something happening, but only high probability of something happening and high probability of something not happening. Ante Newton's laws of motion govern quantum mechanics. Newton's laws of motion and Newton's laws kadama. Okay, because I'll show you from next 3 or 4 slides that Newton's laws were okay. Actually నేను ఇంతకుముందు ఒక వీడియో కూడా పెట్టానా ఏం తెలియదు. Okay, so Newton's laws were preceded by about 1,000 years. 1,000 years ముందు చెప్పారు. ఎవరు 1,000 కాదమా, 16 plus 6, 2,000 years ముందే చెప్పారు. ఎవరు చెప్పారు? ఆచార్య కన్నడ. Okay, what are you talking, sir? Is it reliable? Don't have to worry because it is authenticated by international community. Okay, only national అంటే మనకు ఒప్పుకో మళ్ళా. Okay, ఇండియా గ్రేట్ చెప్పుకుంటారు సార్. ఓకే, అది తప్పు ఉండొచ్చు. యా గుడ్, అందుకనే ఇంటర్నేషనల్గా ఐ మీన్ యాక్సెప్టెడ్ డేటానే చెప్తున్నాను. ఓకే, so Newton's laws of motion govern classical mechanics. That is to say, if I am to correct it, okay, Acharya Kannada's laws, okay, govern classical mechanics, whereas Schrodinger's wave equation or Schrodinger's laws govern quantum mechanics. Schrodinger's laws, okay, again you have to go for ఏదో చెప్తే మళ్ళీ మీ ఓకే యూ విల్ గెట్ డిస్టర్బ్డ్, అందుకని వదిలేద్దాం. ఓకే, షార్టింజెస్ గురించి కూడా ఉంది. See, classical mechanics cannot give you quantum mechanical results. Classical mechanics లో quantum mechanical results రావు, కానీ quantum mechanics gives you classical mechanical results when approximated to macroscopic level. అంటే అప్రాక్సిమేషన్ లిమిట్ పెడతాం కదా, లిమిట్ ఎక్స్టెండ్స్ టు అట్లా అని చెప్తాం కదా, అట్లా లిమిట్ పెట్టి ఓకే అదే క్వాంటమ్ మెకానిక్స్ని యూజ్ చేసుకుంటే, if you are using the mathematical concept of limits to quantum mechanics, you can get every classical mechanical result from quantum mechanics, but classical mechanics cannot give you quantum mechanical results. Conservation principles are applicable in classical mechanics, and Schrodinger's wave equation is applicable in quantum mechanics along with the conservation principles. Okay, this is a simple okay, I have taken this from this YouTube site, so you can search there. Matter is actually said as particle and wave. Okay, Classical mechanics went on to talk about about it, and you get macroscopic values. Okay, so when you go to waves only, quantum mechanics deals with it. Okay, when you go to the limit of nanoparticles, very small particles in quantum mechanics, then that square will actually lead to your macroscopic, that is classical results also. Okay, wave and particle duality comes into picture only when the scale is considered. What do you mean by scale, sir? Ante when you consider proper dimensions, ante very small dimensions unnappude particle and wave nature can simultaneously be, or to say easily be seen. Okay, so wave nature chudalante you will have some experimental results to see the wave nature of matter. That is what is your division Jarrah experiment. We'll come to that a little later. Utshepanam. Utshepanam implies